Hello guys, so we're on 5.1 and we're going to talk about the unit circle. Now, earlier we've worked with trigonometric functions and their ratios, so we can actually work with right triangles. I'm going to now put those right triangles inside of something called a unit circle. So what is a unit circle? Well, as the name implies, it's a circle with radius 1. It could be 1 feet, it could be 1 feet, or 1 inches, 1 meter, etc. It just has unit 1. So if I draw a line from the center to the boundary of the circle, that distance is 1. Right? Now, if we recall, with a trigonometric function, our inputs are angle measurements. So we got to figure out things in terms of angle measurements with this unit circle. I've constructed all these dots here. These are going to be location of where the angle measurements lie. Now, to the right side of this screen, we have angle measurements that are common on the unit circle. We start with the lowest, 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, and it's going to continue going on all the way to 360 degrees. The left side of that equal sign are the conversions in radian units. I do expect you to give it a shot and turn these all into radians. You'll see that in lesson task number 2. Alright, so our angles that we've constructed and everything, they always have to have two rays, the initial side and the terminal side. The initial side is always going to be from the center of the circle to the boundary to the right of the circle. So it's that blue arrow I have constructed in the image. The center of the circle is the origin of the XY plane. That's going to be located at 0, 0, because I did not move left, right, etc. That is dead center. Now, I care about the location of the green dots, the horizontal distance from the center of the circle to the green dots. In particular, this first angle I am going to be working with is 0 degrees or 0 radians. Okay? They're both the same. Now, what is the location of this green dot? If the center of the circle is located at 0, 0, that means I did not rise at all. I only run. And I run all the way to the right, so it's a positive value. So I need to know the distance from the center to the edge of the circle. Well, it's a unit circle, so that distance is 1. So this guy right here, this location, is precisely 1, 0. For 0 degrees, we have a terminal point, which is going to be on the terminal side of 1, 0. I moved right 1, and I did not go up at all from the center. Now I'm going to work with the next smallest unit, 30 degrees or pi over 6. So I'm going to go to the next point of interest over here, and I'm going to write 30 degrees or pi over 6. Now, again, you need your terminal sides. In the first one, our initial side is the same as our terminal side because it's 0 degrees. I didn't move them any distance of the opening. However, this time I got to raise the terminal side up by 30 degrees from the initial side. Boom. So let's construct that. If I construct that, I have this as my terminal side. Now I got to find the x and y value, or the point, for this green dot. Well, this is actually a bit complicated because I know this purple line is unit 1, but I don't know the horizontal and vertical distance. Because if I want to calculate the horizontal distance, this is the horizontal distance right here, from the center to those dotted lines. The vertical distance is also a bit tricky as well. How high is this right triangle? Well, the key is that it is a right triangle. So now I know this angle measurement is 30 degrees. Boom. So I'm going to pull this right triangle outside and work with it. I have a right triangle. where this angle right here at the in between the initial side and the terminal side, that angle is 30 degrees. That's the one we care about. We need to find x and y values for them. Well, the only information I have on this right triangle is that the angle is 30 degrees, it's a right triangle, and the hypotenuse is the radius of the circle. So that is 1. Now if you notice, this is a 30, 60, 90 right triangle. So we can now use our rule by 30, 60, 90 rule. That means the hypotenuse in particular, if I were to draw the other angle, let me do that real quick. This is going to be 60 degrees because they have to add up to 180 degrees. Opposite of the 30 degrees to the hypotenuse is half that amount. So this is 1/2. And then opposite of the 60 degrees is always square root 3 times opposite of the 30 degree mark. So this is square root 3 over 2. This is why it's important to work with these right triangles in particular. So once we have that, the bottom one represents your horizontal distance from the center. Remember, your center is located here. This is 0, 0. I care about where is this point at. Well, I went to the right square root 3, and I went up 1/2 to get to that point on the circle. So this guy is located at square root 3, square root 3/2, 1/2. Boom. All right, so that's fine and everything. That's nice. Why is this useful anyways? What is the purpose of all of this? I've gotten that. Nice. Well, we're going to be able to calculate things like sine of pi over 6. We're going to need to be able to calculate stuff like that. Well, how do you calculate sine pi over 6? That's the same thing as saying sine 30 degrees. You don't have to make that conversion. Eventually, we will be accustomed to radians. But sine of 30 degrees. Well, sine is exactly opposite over hypotenuse of our angle measurement. So I'm going to look at this triangle, look at the 30 degree angle, and now I'm going to figure out where is the opposite from 30. Opposite is equal to 1/2. And my hypotenuse is 1. Now, any number divided by 1 is itself. So this value is 1/2. This means that sine of pi over 6 is equal to 1/2. Okay? And you can see it later down here. I've given you the work for that, etc. But that's the main idea. All right? Now, this also means now we know how to calculate cosine of 30 degrees. That's adjacent over hypotenuse. We can use that exact same triangle, which is very nice. If I use that exact same triangle, I have cosine of 30 degrees. The adjacent to that 30 degrees is square root 3 over 2. And then my hypotenuse is still 1. So with the results, cosine of pi over 6 is going to give me exactly square root 3 over 2. In your calculus, you will have to choose the correct mode for these results and everything. And to change that, you can click on mode on your calculator and scroll down to where it says degree or radians. Degree, deg, or rad is what it'll say on your calculator. All right. So these are the importance of the unit circle. To calculate these trigonometric functions output, if I give you a specific angle measurements. The specific angle measurements we're going to be working with is 0 degrees, 30 degrees, 60 degrees, 45 degrees, 90 degrees. And I apologize for not saying in easy order, but that's the main idea. Now, this is actually very powerful because in every single one of these pieces of the unit circle, you notice that, hey, the hypotenuse is always the radius. So maybe you want to make that note, the hypotenuse is always the radius. Which means that if I wanted to calculate the sine of an angle measurement or the cosine of the angle measurement, the final piece is dividing by 1 or dividing by the hypotenuse. Which means that I only care about the opposite, and I only care about the adjacent. So we get this powerful statement. In particular, we have the final thing we can say is that sine, if I calculate sine of an angle measurement, I only care about the y value of that dot, or the height of your right triangle. If I want to calculate the cosine of an angle measurement, I only care about the horizontal distance, or the x value of that guy. Now, this is all nice and dandy and everything for 30, 60, 45 degrees, etc. Once I get into this point right here at the very top, let's call this the North Pole, the dot on the North Pole. Well, this guy right here, again, the center is 0, 0. If I'm going from the center to the very top, I did not move left or right. I only go up. So this guy has a distance of 0, sorry about that, 0, comma, and now, and this is for pi over 6, or this pi halves, which is 90 degrees. All right, this is located at 0, comma, and I went up 1 because the radius is 1. 1. Right? Now, any angle measurement that we work with that is past 90 degrees or pi halves, when you construct your circles, you have to construct something called a reference angle. A reference angle. What is a reference angle? It says over here, these are angles in the unit circle where the base of the angle lies on the x-axis. To calculate these reference angle, I'm going to call it theta with a hat. You must add or subtract your inputs by multiples of 180 until the reference angle is between 0 and 90 degrees. So let's give an example of that. And over here, there's some work, etc., but I'll show you the main gist. All right, we're going to work with the angle measurement 210. Now, if you've ever worked with anything in terms of degrees, let's just label out some basic degrees. This is 0 degrees. This is 90 degrees. That's where the opening of the angles is for my terminal, or my initial side. Let me draw my initial side. This is my initial. And then past that, we have 180 degrees, and this one right here is 270 degrees. If I keep going on, I add 90 degrees more. Okay, so that's the idea there. Now, if I want to work with, let's say the first one says tan of 7 pi over 6. Well, that's, in conversion, is tan of 210 degrees, which is nice. So now we have an idea how we can work with this guy. Well, where does the angle measurement 200 degrees live in? It doesn't live in the first quadrant. Doesn't live in the second. It lives in the third one somewhere. I don't know exactly where, but I'm going to put a dot in the third quadrant. Boom. Now I'm going to construct my hypotenuse of the right triangle. It starts from the center of the circle to the boundary of that point, or boundary of the circle itself. So my terminal side is going to be all the way over here. Use a different color. Now this is a bit weird because I stated earlier your initial ray is always on the x-axis, right? So this is what your angle looks like. It looks like this. Sorry about that. It is this opening right here. However, it's not so nice to work with angle measurements that are over 90 degrees. So what we're going to do is construct a reference angle or a reference triangle. And how do we construct that? We're going to look at our terminal side, and then we're going to construct a new initial side. The initial side must be on the x-axis. It must be on the x-axis. So I'm going to draw a new initial side over here. It has to be on the x-axis. So now I have an idea of what my angle looks like, my new angle that I'm working with. So instead of this guy being over here, 210 degrees, I can also work with this smaller angle right here. Well, how much angle measurement is that? Well, I know that the entire guy is 210, and I know that half of the circle from all the way from here to here is 180 degrees. I just got to subtract the two. All right? So if I subtract the two right there, you get that this angle measurement is 30 degrees. And I can construct my right triangle here from this point, and I just drop a straight line down, boom. So it's an upside down right triangle that we're working with, but the same rule still applies. So now I'm going to pull out that right triangle real quick, and it's going to be upside down, of course. My point of interest is over here, but the idea is that this angle measurement is 30 degrees. If I wanted to calculate tangent of it, well, tangent is opposite over adjacent. So I got to figure out the amounts for opposite of 30 and the adjacent of 30 degrees. Well, I know the radius or the hypotenuse is 1. No matter what, that stays 1. So that part is nice. Okay? This is a 30, 60, 90 triangle again. So I can fill out the other information. Well, opposite of the 30 is half of the hypotenuse, so this is 1/2 here. And then adjacent right there in this particular, or opposite of the 60 degrees, is going to be square root 3 times 1/2. So square root 3 over 2, which is nice. Now, from the center of the circle, we do have to account a few things. Even though I say these are the side measurement, technically I went down. I went to the left and I went down. That's going to play a role. Instead of going up and right, I went left and down. Those are like negative values and whatnot. So if I calculate tangent of 7 pi over 6, which is equal to tangent of 210 degrees, which there's two ways to think about it. The first way is to think of it as sine 210 degrees over cosine 210 degrees. Oops, I'm sorry. That's an identity. We can do this as, where is it at? Tangent of, and then the reference angle I'm working with is 30 degrees. However, I have to consider this location here in particular. It is in the third quadrant. I went left and down. That means in particular, when I do this calculation, my answer will be positive because if I went left, that turns it negative. If I turn right, it turns it positive. So if you think of it like this, the opposite is negative, and the adjacent is also negative. So this is negative divided by a negative, which is a positive. So it's just the opposite over adjacent, which is opposite is 1/2, and this is divided by square root 3 over 2. And that's going to give me precisely 1/2 divided by square root 3 over 2, 1/2 times 2 over square root 3, 2 over 2 root 3, 2's cancel out, 1 over root 3, and then you have to rationalize this guy. So multiply by square root 3 over square root 3, square root 3 over 3. Okay. And I should have rationalized over here, so make sure you have that done, etc. So that's the main gist of how you're going to construct these unit circles and whatnots. And you might have examples where your unit circle, let's say we work with 3 pi over 4. 3 pi over 4, that's going to be equal to 135 degrees. Right? If we work with this in particular, then that means that I'm going to be working with something in, this is 0 degrees, 90 degrees, 180 degrees. I'm going to be working in the second quadrant. My angle might live somewhere over here. Alright, then my terminal, this is my terminal side. And remember, our initial side always starts with this side over here, the x-axis. However, I can't really work with a big angle like this. This is 200, this is 135 degrees if you want to think of it like that. I can't really work with that. Instead, I work with the reference angle, the one that's between 0 and 90 degrees. And I construct a new initial side on the x-axis. It has to be on the x-axis. So I'm going to construct a new one over here. If I construct it on the right side, well, that angle is still bigger than 90 degrees. But if I construct it on this side, then it's going to be less than 90 degrees, which is nice. So the angle I care about is over here. And then in particular, this angle measurement that I can work with, or I guess you can alternate which way you want to go. As long as you work with the positive angle, you're good to go. But in this case, that angle measurement over here, it's going to be 180 minus 135 degrees. So 180 minus 135 degrees, it's going to give you 45 degrees. This is a 45 degree angle. So if I construct my right triangle now, I don't have a 30, 60, 90 this time. I have this 45 degrees, and my point of interest is up here. The hypotenuse is always 1, or the radius, etc. Now, with the 45, 45, 90 degree, it says that, hey, opposite of the 45 degrees, they will be the same for the other opposite of the 45 degrees, but in relation to the hypotenuse, it's going to be divided by square root of 2. All right, so these guys are 1 divided by square root of 2, but you have to rationalize that. If you rationalize that, 1 over square root of 2 times square root of 2 over square root of 2, square root of 2 over 2. So these guys are square root of 2 over 2 values. All right. And if you wanted to find a sine value of 135 degrees, you just check, did you go up, down, etc. Remember, sine outputs represents the y values. Cosine will represent the x values. So in particular over here, I am asked to calculate cosecant. Cosecant is 1 over sine. It's the reciprocal of that. So I'm just going to do 1 divided by square root 2 over 2. All right? And it's in the second quadrant, so I went up, so the value stays positive. If it went down, the y value would be negative, so that would change. Okay. That covers it for 5.1. I will catch you guys next time. Take care.